Lesson 2-3, Example 2. Our objective is learning to write expressions for tables and sequences. And here we have a sequence of numbers: 7, 10, 13, and 16. And we could write this just as a list of numbers in a sequence, but I've chosen instead to put it in a table. And that table allows me to organize this information in a little bit different way. I can also show what position each of these numbers is. So here's our sequence. This is the position is the first number in the sequence, the second number in the sequence, the third number, the fourth number, and so on. Now I could sit here and look at this sequence and figure out what the next one's going to be. I see from 7 to 10, that's going up 3. From 10 to 13, that's adding 3. And from 13 to 16, that's also adding 3. So I'm going to be pretty sure that my next number here would be 19 because it's adding 3 each time. But what if I didn't know this part of the sequence? What if I was only given the position of that term? And that's what we want to find out. So we need to look for a relationship between the position of the number and the value of that term. So let's see if we can figure this out. I'm just going to use a guess and check method. And I'm going to start off by thinking, well, what's the relationship between 1 and 7? Well, I could think that 1 plus 6 is going to be 7. But I also need to make sure that this expression that I'm coming up with works for all of this data in the table. So I'm going to try it out with 2. So if my position is 2, if I add 6 to that, I get 8. Well, I'm hoping to get 10. That's not going to work for me. So I need to try something else. So I'm going to start with position 1 again, and I'm going to think, well, maybe instead of adding 6 to it, maybe it's a multiplication operation. So I'm going to multiply by 7, and I get 7. Okay, that's working so far. So let's try it now for the second position. So 2 times 7, I'm going to get 14. Well, again, I was looking for 10. That's not going to work. So I need to try something different. Well, let's keep with that multiplication idea. What if I multiply position, so position 1 times 3? At first that might not make sense, but let's go with it. 1 times 3 is going to be 3. And how am I going to get 7? Well, if I add 4 to that, let's add 4 to that. That gets me 7. Okay, let's try it with our second position. So now I have 2. I'm going to multiply it by 3 this time. I get 6. And just like I did before, I'm going to add 4 to it. Hey, that works. I'm getting 10 now. Let's see if this continues. I want to make sure that it works for all the data in my table there. So position 3, I'm going to multiply by 3 again. Gets me 9. And add 4. 9 plus 4 is 13. And for the third position, it's 13. So far, so good. Let's try it for our last term there. So 4 times 3 is 12. Add in the 4, and I get 16, and that's what I want. So our final spot we need to look is n, this variable. So whatever the position is, I want to know whatever the position is, I want to be able to figure out what the value of the term is. So I'm just going to use n as my next position, because n, even though it's a variable, it's still just a number. So n, and I multiply it by 3 just like I have all the other times. And I can write that as 3n. You'll see that sometimes with a 3 right next to a variable. That means there's a multiplication between those two. Now, on all the other ones I added 4, so I'm going to add 4 this time. Well, unless I know exactly what the value of n is, this is as good as I can get right now. And this is my expression, 3n plus 4. So whatever n is, if I put in a number there, I multiply it by 3 and then add 4. So this is my algebraic expression for this sequence, 3n plus 4. And I've shown that that works by putting that in, each position in, and coming up with the value.